So today we're going to finish up chapter 7 with 7.6. We're going to talk about the double angle and the half angle identities. So this is just more identities to add to your list. As I did in the previous video, we said, hey, we have sine alpha plus beta, and we know what that equals. We know that this is equal to the sine of alpha cosine of beta plus the cosine of alpha sine of beta. So we know that. But what if alpha equaled beta, and let's say they both equal theta, okay? So what if alpha and beta were the same value, like 30 and 30, or like 40 and 40, or 100 and 100, or something like that, right? So then this would become sine of theta plus theta, which would be the sine of theta, the cosine of theta, plus the cosine of theta, sine of theta, okay? So then this would become 2 theta, and this would become sine of theta, cosine theta, sine theta. This would be 2 sine theta, cosine theta. This is the double angle for sine. Okay, so this is an extremely important one. This comes up so often in simplifying calculus problems. I always have students that get calculus problems wrong. I just actually had an email right now about a student that was struggling with a calculus problem, and it was because of the double angle. So please make sure that you guys memorize this one. This is like your go-to core identity. You never can forget. I mean, obviously you still have sine squared theta plus cosine squared theta equals 1, and then all the variations that you can get from that. But this is another huge one, okay? So instead of going through the motions for the other one, you know what? Let's go ahead and do it. Let's say we have the now let's do for cosine. So same thing, cosine of alpha plus beta equals, and now we know that this is the cosine of alpha, cosine of beta, minus sine alpha, sine beta. But what if alpha equaled beta equals theta? So basically, once again, they're the same angle. This would become the cosine of theta plus theta, and this would become the cosine of theta minus the sine of theta, sine of theta. But this would become, the cosine of 2 theta, and that would equal cosine squared theta minus sine squared theta. So this is the double angle for cosine. But wait, there's more, because you guys remember that up here I wrote this, but isn't sine squared theta worth 1 minus cosine squared theta? And isn't cosine squared theta worth 1 minus sine squared theta? So if that's the case, I could rewrite this as, oops, let's do it in green. So this, just so we're clear, this is the double angle for cosine. But cosine has another one. Cosine also says 1 minus sine squared theta equals cosine squared theta minus sine squared theta. But that's really 1 minus 2 sine squared theta. So that is also the double angle for cosine. But wait, there's more. What if I instead had done cosine squared theta and I converted this guy to 1 minus cosine squared theta? Well, then that would become cosine squared theta minus 1 plus cosine squared theta, but that is actually equal to 2 cosine squared theta minus 1, and that is also the double angle for cosine. So cosine has multiple double angles, but the one I memorize is this one, and then the other two I can build if there's ever a situation where I need it. So these are the two that we'll focus on for this class. So you can use these when somebody asks you to do this. They could say, find the exact value if sine of theta equals 3/5 and pi over 2 is less than theta is less than pi. Okay, so this information over here, you guys, they normally give you to kind of, you should draw your unit circle right away and see where you're at. Theta is then, this means that theta is in quadrant 2, right? Because, wait, did I say, yeah, this looks like a 2, it's not. Okay, so theta is between pi halves and pi. So we know that it's somewhere, oops. We know that it's somewhere in quadrant 2 somewhere, right? We know that this is our angle. So what we're gonna do is we're gonna come over here and we're gonna draw this triangle. And that's my theta, right? And I know that SOHCAHTOA says sine is opposite over hypotenuse. So this is opposite over hypotenuse. So then we have 9 plus b squared equals 25. So b squared equals 16. So b equals 4. So we have 4 there. So now they're going to ask us find the sine of 2 theta, okay? And find the cosine of 2 theta based on this. Okay, so what you do then is you just say, well, this is actually 2 sine theta cosine theta. But I know that the sine of theta is 3/5, and I know the cosine of theta is, what did I say, 4/5. But we're in quadrant 2, so I know cosine, maybe I should have put the negative there, it's actually negative. So then this will become what, -24/25, and that's your answer. Now let's do the same thing over here. Let's use cosine squared minus sine squared theta. So this would be, let me see, cosine of theta would be -4/5 squared, minus the sine is 3/5 squared. So it's going to become 16/25 minus 9/25. So this is going to become what? 7/25. And there you go. So that's how we can use our identities to help us find problems that are seemingly a little bit more difficult. And notice we never knew what theta was. We never found theta. We're just able to answer any questions they ask of trig functions because we know all the information we need. Okay. Let me see what else I got. Let me have you guys try one. This is definitely a test type question. So find sine 2 theta and cosine 2 theta given that sine theta equals 2/5 and cosine theta is less than 0. So take a minute, write this down, and then let me clean this up, 2/5. Take a minute, pause the video, and then try to set this up, and then come back and see if we do it the same. Okay, so first thing we need to do is we draw our circle, we find out where we're at. Okay, so they said that the sine is 2/5, but not only they said it's 2/5, it's positive. So that means we're either in quadrant 1 or in quadrant 2. That's where the sine or the y coordinate is positive. But then they said that the cosine coordinate, cosine of theta, is going to be negative, less than 0. So that means we know we're over here somewhere. So now I'm going to draw my triangle. And I have my theta, right? And now I know that the opposite is 2 and the hypotenuse is 5. So then this has to be 4 plus b squared equals 25. So b squared equals 21. So b equals the square root of 21. So this becomes square root of 21. And I'll put a negative just to remind me. Even though I know the side of a triangle can't actually be negative, it's more to remind me the coordinate. Okay? So now they want to know the sine of 2 theta. Well, no big deal. That's just 2 sine theta cosine theta, but that's just 2 times. Now you guys go back and think of sine theta. They already told us that's 2/5. And the cosine we now know is negative square root 21/5. Okay, so that's going to be -4 square roots of 21/25. No big deal. Now you guys take a minute once again, pause the video, try cosine 2 theta. I'm gonna just try a different one, unpause the video. Hopefully you guys unpause the video. I'm gonna try a different one. I'm gonna try 2 cosine squared theta minus 1, just to see. 2 cosine squared theta minus 1. So 2 times cosine squared, we said was negative 21 square rooted over 5 minus 1. That would be, let's see, negative 2 square roots of 21 over 5 minus 1. I don't see, I shouldn't have done this. I don't like it already. Let's clean this up. Oops, I'm doing the wrong problem. Hold on. Yeah, okay, so this would be what? Negative 2 square roots of 21 minus let's see. Oh, I know what I did wrong. Okay, I know what I did wrong. Hold on. Yeah, I just noticed. I forgot to square it. So this is going to be 2, and then we know that the cosine is negative square root 21 over 5 squared minus 1. So this is going to be 2 times 21 over 25 minus 1. So that's going to be 42 over 25 minus, now 1 we can convert to 25 over 25. So that would become, what, 17 over 25? There we go. Yeah, that sounds a lot better. That's more like it. Okay. You know what? Let me add the double angle. I'll just add it right here. So tan of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. I don't want to go through and do that one, but it would behave the same. But I wanted you guys to have it for that, just in case. So here's the tangent one. Here is the cosine one. Here's the other cosine one. Here's the other cosine one. Remember, they're all 3 the same as this one. Oops. So this one, and this one. These are all 3 the same for the double angle for cosine. And then here is the double angle for sine. These are all the ones you should know for sure, without a doubt. Tangent doesn't come up very often for me, but the other ones definitely appear, and the double angle for sine even more so. So sometimes what can happen is sometimes, let's say oftentimes, these identities oftentimes allow us to solve problems, maybe not even solve, to evaluate or simplify problems that require a less direct approach. Okay. So, you know, somebody could say, hey, simplify. And they could give us sine of 15 degrees, cosine of 15 degrees. Now the problem with that is we don't know the sine of 15. Simplify, find the exact value. We don't know the exact value off the top of our heads. We can get a decimal approximation using a calculator. But what I do know is I do know that 2 sine theta cosine theta is equal to sine of 2 theta, right? So what if I plug that in right here and I said, well, what if this was 2 sine 15 degrees cosine 15 degrees? That would be amazing, right? That would then be sine, well, what's the double of 15 degrees? That would become 30 degrees, right? That makes sense? But here's the problem, the 2. I need a 2 in front, and I don't have that 2 right there. So what's the, I need the number in front. See how the number in front is a 1? That means that this number in front must also be a 1. So how can I make 2 sine theta cosine theta have a 1 in front? I'm going to divide it by 2. I'm going to divide it by 2, right? So that'll cancel, right? But the problem is, how do I explain this? Let me show you guys. Let me do this again. So we don't have the perfect double angle. So what I'm going to do is I'm going to say, well, what if I have 1/2 sine, 1/2 of 2 sine 15 degrees cosine 15 degrees? Would that be legal now? Now, if I wanted, I could cancel this and this, right? Those would cancel, and I would get 1. So I haven't changed the value of the problem. But what I'm going to do is I'm going to leave the 1/2 there. I'm not going to cancel, because I know that this is worth sine of 30 degrees, right? Because it doubles whatever the angle is inside, okay? And that would then become 1/2 times the sine of 30 degrees, which is 1/2, so we would get 1/4. How do I know I'm right? Well, what if I rewrote 2 sine, how about this? What if I rewrote this? Wouldn't this be 1/2, and this would be 2 sine 15 degrees cosine 15 degrees? That's exactly what I would have gotten here, right? And that's also the same as this, because the 2's would cancel. So I know that this works because I can clean it up. You see how it's kind of like not direct, like you can't just straight up do it. You have to like multiply by 1/2 to clean things up. What if I was asked to write sine 3x in terms, let me see, in terms of sine x? And I'm assuming we should only try to do it with first powers. Or I mean only with sine 3x. We should be able to write it with only sines, but we'll need more than first powers probably. So what I could do is I could write sine 3x equals sine of 2x plus x, right? And we know that this is the sum or difference formula for sine. So this would be sine of 2x cosine of x plus cosine of x sine of 2x. Oops, I think I wrote that wrong. I think I wrote it wrong. Yep. Cosine of 2x sine of x. Now this is 2 sine x cosine x. You know what? I'm going to write this in red. This is 2 sine x cosine x times cosine x plus, now we have a bunch of choices for cosine. I'm just going to stick to the normal one. I'm going to do cosine squared x minus sine squared x times sine x. Now let's see, this will be 2 sine x cosine squared x plus sine x cosine squared x minus sine cubed x. So we still have some cosine squareds floating around. So what I'm going to do, I think, is I'm going to convert them. This would be 1 minus sine squared x, right? Plus sine x, 1 minus sine squared x minus sine cubed x. All I did was I used the Pythagorean identity. You guys should have this memorized, right? That and that are worth the same. So now this will be 2 sine x when I distribute minus sine cubed x plus sine x minus sine cubed x minus sine cubed x. So let's see here. We have 3 sine x minus 3 sine cubed x, it looks like. Wait, let me see here. Do I have, oh. I think I forgot to distribute this 2 right here. So this 2 sine x was supposed to distribute. So this should be a 2 right there. Sorry about that, you guys. So then that makes that a 4 sine cubed, oops, 4 sine cubed x. So notice I wrote this entire problem, sine 3x, and it only has a single angle. It's not a double or a triple angle, it's just sine x, but I did need to bring in a third power. So this is something that happens a lot of times when you use double angles to clean things up. Sometimes you end up with bigger powers, but at least it's not a double angle any longer. Now we can establish some identities. Or verify. So we can say that sine 2x is equal to 2 tan x over 1 plus tan x. Well, we already know that this is 2 sine x cosine x equals 2 tan x over 1 plus tan x. Let me see what we can do here. You know what, when all else fails, rewrite everything as sine and cosines. Let's see if this gets us to where we want to go. So this would be 2 sine x over cosine x divided by 1 plus sine x over cosine x. And again, I don't know how bad this is going to get. Let's see. 2 sine x cosine x. And I'll just put over 1 because it may come in handy. And this is 2 sine x cosine x. Now, if I want, I could multiply this by cosine x over cosine x. So they're, the same denominator. And I could divide by cosine x plus sine x all over cosine squared x. Let's see if that does anything. 2 sine x cosine x equals, I'll put over 1 just in case, 2 sine x over cosine x times cosine squared x over cosine x plus sine x. So far, just a little bit of cleanup. I don't see anything going crazy here. That cancels with that, and we just have one of them. Let's see here. So then this will become 2 sine x cosine x equals well, it's multiplying, so 2 sine x cosine x all over cosine x plus sine x. Let's see here. I don't see anything good happening. I think I might have done something wrong here. Oh, there's a typo. Ugh. There's a typo, guys. Oh, man. Okay, we got to start over. There's a typo in the problem. It's supposed to be a squared there. That's why I couldn't get it to work. It's 1 plus tan squared x. Okay, so sorry about that. I just saw that my notes have a typo in it. And then I actually fixed it, but it's really light pencil, so I couldn't see it. Okay, if I was editing, I would edit this video out of the video, but I'm not. So let's just kind of go with the flow. So this will become 2 sine x over cosine x. We already know that. Divided by 1 plus sine squared x over cosine squared x. So 2 sine x cosine x equals 2 sine x cosine x divided by, and now we're going to do the same thing but with cosine, so this will be cosine squared x. See, I'm just going to do cosine squared x over cosine squared x. That way that this has the same denominator as the sine x squared x over cosine squared. So this will be cosine squared x plus sine squared x all over cosine squared x. Now this is going to be nice. So I guess it was worth it. Sine x cosine x equals now 2 sine x cosine x times cosine squared x over cosine squared x plus sine squared x. Looks terrible, But you guys know that this is just worth 1. Sine squared plus cosine squared equals 1. Sine squared x plus cosine squared equals 1. This cancels with that, and you're left with the first power. So now we have 2 sine x cosine x equals 2 sine x cosine x. Check. We verified. Sorry about that mistake, you guys. It was a typo. So yeah, you can verify identities. You can do all kinds of stuff with this. Let me see what else I got here. Oh yeah, now we got to get to the half angles. Now the half angles, and there's other variations that we can use. So the half angle says that the sine squared of alpha over 2 is worth 1 minus cosine alpha over 2, okay? We also have cosine squared alpha over 2 equals 1 plus cosine alpha. Yeah, we're not going to have time to go into all the detail of this, but just kind of trust. Squared alpha over 2 equals 1 minus cosine alpha over 1 plus cosine alpha. And that one's similar to what I showed you in another problem from a different video. Now, if these are the case, and these are huge in calculus, they're variations of the double angle that I often will use in my calculus class, especially in Calc 2. What we can do is or the half angle, what we can do is we can square root both sides. And if we square root both sides, we end up with these alternative formulas that say the sine of alpha over 2. So instead of doubling the angle, you're cutting it in half, is equal to plus or minus the square root of 1 minus cosine alpha over 2. So just basically the formula square rooted. This will be cosine, I'm sorry about that. Cosine alpha over 2 will equal plus or minus the square root of 1 plus cosine alpha over 2. And notice both of them use cosine in the answer. And that's also noticeable here as well. Whether it's sine squared or cosine squared alpha over 2, it's 1 minus or 1 plus, but both times it's cosine. And then the tangent used much less often. Tan alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Just not used as often, but it's still there. So if you square root both sides, and again, the plus or minus is determined. So plus or minus is determined by what quadrant you are in, okay? So the way we can use this is pretty straightforward. So if somebody says, hey, find the cosine of 15 degrees, we already know that we could use, the sum or difference formulas for that. But what we could use also is we could now say, well, the cosine of 15 degrees isn't that the same as the cosine of 30 degrees divided by 2? So now this becomes my alpha. So now I go into the problem and I say, well, I remember right here, it says if you can rewrite it as cosine alpha over 2, which I just did, I can do plus or minus the square root of 1 plus cosine of alpha, but in this case, alpha is 30 degrees and divided by 2. Now, if I'm at 15 degrees, what quadrant am I in? I'm in quadrant 1, so that means that it's going to be the plus, and I'm going to do 1 plus the cosine of 30 degrees is square root 3 over 2 divided by 2. So normally they want you to clean this up a little bit. And I'll ask you to clean this up in your work. So this will actually be 2 plus the square root of 3 over 2 over 2, right? So that's really over 4. So then this becomes 2 plus the square root of 3 square rooted over 2. Because the 2 divided by 2 becomes, it's technically 2 plus square root of 3. It's technically this. And then times 1/2, or divided by 2 is the same as times 1/2, so that becomes a 4. But the square root of 4 is 2, so the denominator actually gets to come out of the radical. So this is your answer. So this is how you can use the half angle. A test question might be, find the exact value of and then I'll just list sine alpha over 2, cosine alpha over 2, and tan. Now, let me see. Do I want to do tan? Nah, we're okay. You guys could do tangent. The ones I have worked out are tangent or sine and cosine, so I'll hold off on the other one. I don't want to mess that one up. So, and they're going to tell us, find the exact value of, you know what, let's say of the following if cosine of alpha equals -3 over 5, comma, alpha is between pi and 3 pi over 2. So we know we're in quadrant 3. That's what we're basically saying. We know we're in quadrant 3. Okay, so they gave us a little bit of information. I'm going to do this. I'm used to doing this now. So I'm going to do that. So I now have my triangle, and this is now alpha, right? And I know that this is -3 over 5. So I know that has to be 4. I've done enough of these, right? To this point where I know that has to be the value of 4. So they want to know now, find the sine of alpha over 2 and find the cosine of alpha over 2, okay? So here's the rub. I did this in a different video. Since we know that pi is less than alpha is less than 3 pi over 2, that's not exactly what we're dealing with though. We're dealing with pi over 2, so we have to find out, right? So we have to find out that this is now, our alpha over 2 is somewhere between this. Okay, so we're actually 3 pi over 4 and pi halves. So we're even more limiting what it is. We're actually over here now with the pi over 2. Okay, so keeping that in mind, if I want to find sine alpha over 2, I know that that's worth 1 minus the cosine of alpha divided by 2, right? The thing is I know the cosine of alpha. The cosine of alpha, they told me, was -3 over 5. So this is going to be the square root of 1 minus -3 over 5 divided by 2. When we clean this up, I think I will get, let me see, this will be 5 plus 3. So this will be 8 over 5 times 1/2. That cancels with that, and we're left with the square root of 4 over 5, and that is 2 over square root of 5, but you guys aren't allowed to leave that. So you guys, you will have to write this as 2 over the square root of 5, which is 2 square roots of 5 over 5. And that would be your answer. Now the thing is since we're dealing with sine of alpha over 2, when we're dealing with this, that is going to be in quadrant 2, even though the original problem had us in quadrant 3. So in quadrant 2, my sign is actually positive, okay? So we're going to use positive on this one. Now let's do this one, cosine of alpha over 2. We know that this is once again going to be the square root of 1 plus cosine alpha divided by 2, right? So then this will be 1 plus, now cosine is still -3 over 5. Oh, I guess I didn't even need to solve for 4 because we never needed, I forgot. It's going to be -3 over 5, right, divided by 2. So then this will become the square root of, so that would be 5 over 5. So it'd be 2 over 5 divided by 2, which is the same as the square root of 1 over 5, which is the same as the square root of 5 over 5. Okay. However, in quadrant 2, What is cosine? Cosine is negative in quadrant 2, right? Right there, right, quadrant 2. Oh, that's really ugly. Cosine is negative in that quadrant. Okay, so that's how you can use the half angles to solve some problems. One last one, give you guys, this is a nice one. So what if I gave you the sine of 22.5 degrees? Well, you guys know that that's actually the sine of 45 degrees divided by 2. So then you guys hopefully can go from there. You guys know that this is going to be 1 minus the cosine of 45 degrees divided by 2. But you know that will become the square root of 1 minus the square root of 2 over 2 over 2. And that will be what? The square root of 2 minus the square root of 2 over 2 times 1/2, which is actually the square root of 2, square root of 2 minus the square root of 2 all over, over 2. Okay. Yep, that's it. And we're in quadrant 1, so we're good. We don't have to stress out about it, okay? About the negative sign. So this is just some problems that you guys could see. This is how we can use the half angles and the double angles. Just kind of be careful with the restrictions that you sometimes enforce on yourself by doing the problem from pi halves or from when you do alpha over 2. The sign kind of has restrictions that you have to look out for, okay? But this is 7.6. This should get you started. I'll post the homework in a little bit, but that'll do it for tonight.